Friends, it's C and I'm back with another video on debunking, bro. I'm getting debunked by the debunkers on YouTube. They're gonna be debunking they're gonna be debunking this forever, bro. Get it? All right, here's just one example, okay? I'm not gonna bring out 100 examples, but one is enough. The relationship between myonuclear number and protein synthesis in individual rat skeletal muscle fibers. Okay, they're not gonna do the test on a human, but they know it would show up the same in a human as in a rat, okay? It's not something you're going to tear open a person to see how many nuclei they had inside there after rigorous exercise. Okay, man? Okay, so what is nuclei associated with? Well, you're going to find out right now, okay? Here's the abstract. Skeletal muscle has numerous nuclei within a cell. Yes, we know that. It's highly myonucleated. It's part of the superfamily. The nucleus is considered as the central organelle for muscle protein what? Synthesis. Remember this MPS, muscle protein synthesis. It is the central organelle for protein synthesis. Without him, you cannot synthesize any more protein synthesis for growth to support further muscle growth. All right, here's the proof. So they're going to find out whether this is true or not. However, it is unclear whether myonuclear number is associated with MPS capacity within the individual fibers. Well, we're going to find out if it is or not. Okay, we're going to find out right now. So therefore, the purpose of this study is to find out. Okay, guess what they found right here at the top, right there at the very top. We found, after vigorous, what do they say here? They did some vigorous, whatever, exercises. I know, you don't want me to, I'll go through this part, okay? So they did some high intensity muscle contractions. You know what that's associated with? Muscle injuries. Okay, they got a lot of muscle injuries. They got a donation of these nuclei. We found that myonuclear number was positively correlated with what? MPS, protein synthesis, muscle protein synthesis in individual muscle fibers in the basal condition. There you go. Need I say more, friends? Need I say more? You need these nuclei to support further muscle growth. You want to know why? Want to know why? I'm going to tell you why. This is why. This is why you need it. All right? This is the reason why you need it. So, oops, don't know why it said that. Stupid thing, man. Here's why. Or actually, no, I don't have to bring up this one. You already know the chart. All of you know this chart. Myonuclear domain size limit. Yes. This is why you need it. You want to know why you need it? Because this is why you need it, friends. Because it reached an MND size limit during hypertrophic process. See that? MND size limit. Because MND size has a ceiling limit during hypertrophic process beyond which extra myonuclei are donated by satellite cell to do what? Support further muscle growth. So what supports further, what is the driving factor of hypertrophy to hypertrophy myofibrillar? I'm not saying sarcoplasmic or getting fat hypertrophy and getting fat, bulk dieting and putting blood in your fucking blood restriction, I don't know, lactic acid, inflammation, swelling a cell and all that. I'm talking about furthering the myonuclear domain size limit, the myofibrillar. It has a domain limit. What do you need? Nuclei. Without them, you can't synthesize protein. You can't further that domain. End of story, bro. Get it? And that's for the myofibrillar. There you go. They synthesize protein. Without them, you can't further this domain. So there has to be somewhere for them to, there has to be somewhere for the progenitor cell when it does wake up that it will split, divide, and increase in number. So it would donate its nuclei to what? The cracks and the domes. It's going to donate its nuclei to where? The cracks and the domes. There has to be a relative amount of damage to that myofiber for it to donate its nuclei. You understand me? Yeah. The cell can only get so big. It has an M&D size limit. That's why you get a donation of them in the beginning. When you first come in, you're untrained. You're untrained. You get them in the beginning. You're untrained, like it says there. Remember? Where is that? Fuck, I hate these buttons, man. Can't hit them properly. Once upon a time, here we go. Because what? Because right here. Because untrained people first training satellite cell get what? They get muscle damage. Untrained people get what? Damaged. Untrained people get what? Damage. What do trained people get when they go to the gym, when they're trained now and they're adapted? What do they get? They get this? If you think that you're going to the gym and you're going to get this every time you lift weights, you're going to get a donation of that. And every time you lifted a weight, you'd be fucking massive by now, wouldn't you? You'd be fucking bigger than the Incredible Hulk and everybody walking around in the street. Every time you lifted a weight and you were to get this donation and all that, and these muscles would hypertrophy just like that, then why is everybody small in the gym chasing this elusive muscle? Because muscle is tightly controlled under tightly controlled mechanisms like repeated bout effect, myostatin, follistatin, and the progenitor cell, satellite cell. He doesn't just donate his nuclei just like that. He's just going to donate his nuclei to that domain to synthesize protein. But me particularly, when I'm getting damaged, I'm growing more myofibrillars. You understand me? When you get damaged, you're growing more myofibrillar. You're growing density of the muscle fiber. I'm not talking about the mass of a muscle fiber. A muscle fiber, you can get it so big, that mass can only get so big, and then it ends. It's not going to get any bigger. Now, how big does it get? I don't know. Some people equate it with, well, I reached my genetic limit, my newbie gain limit, or I'm a hard gainer, because they failed. At some point, they failed. They think it's a plateau, but it's not a plateau. You'll need to cause injury to the muscle fibers, a relative amount of damage to get the progenitor to split, divide, increase in number, donate its nuclei to the cracks and the domes. It's complex, man. It's complex. Sometimes it's just regenerative. It may not donate its nuclei. But if it sees that the muscle fibers have been torn apart, well, then it's forced to donate its nuclei to strengthen the muscle fibers. And if you get a donation of these nuclei and myoblasts and myotubes, well, now it becomes resilient from being broken, and that's the reason why it's donating its nuclei. It's trying to make it a lot stronger and resilient. See what I mean? And though you have a donation of these nuclei, you can only see them in a microscope. How do you see them here in hypertrophy? How do you see them? When protein synthesis exceeds that breakdown, you can see the mass of the cells, the mass. So you have to shut off the catabolic hormone to build up these contractile proteins. Otherwise, you won't see the mass on the myofibrillar. You'll just be shooting constantly uphill. Oh, well, I'm eating a chicken leg, or I'm eating a pizza today, or McDonald's tomorrow. That's not going to do it. It has to be consistent for quite a long time, the shutdown of that catabolic effect to cause the contractile proteins to build up. And the nuclei will definitely build them up. And you'll lift heavier, so you'll get more adaptations. You'll get some of this damage when you lift heavier. When you get bigger, you get stronger. Yeah. Look, think about it. If you shut off the catabolic hormone, well, the catabolic hormone converts to an androgen, so it doesn't have to compete with the myocytic androgen receptor anymore, giving you more force production. Thus, more force production. Thus, there's a cancellation in the breakdown in proteins. Now you're building up contractile proteins, more contractile proteins. Listen to the word contractile. You're contracting. You're able to contract heavier weight because you're bigger now and stronger. The more contractile proteins you build in a myofibrillar, the stronger you shall get. You understand me? The more myofibrillars and the more contractile proteins equals more strength. So if you want to get stronger and move with the body weight and the strength together, that is more efficient than just lifting a heavy weight in the opposite direction and being a small guy pretending he's a strong guy. Get it? I'll see you in the next one, man. Tell us what you think about that. Like, subscribe, support the channel. I'll see you in the next one. Ciao, friends. I gotta go.